Hello everybody and welcome to my channel. This is a follow-up video to my previous one, which I dared to suggest that this preamp could be a bit good. And whilst lots of you have decided to build this or own it already and tend to agree with that comment, one or two people have suggested that it's just cheap Chinese crap. Whilst I respect everybody's opinion, I have to say that most of the comments are largely people that are somewhat biased towards spending $500,000 million on a preamp, and mainly people that haven't actually built it and listened to it. Everybody has an opinion, of course, and I respect everyone's opinion. Don't necessarily agree with it, but I respect it nevertheless. Anyway, what has prompted me to make this video, if it was made out of audiophile components, it will be more wonderful. In conjunction with Ron in America, my colleague on this, he has built the same product using the same PCB, but he has used so-called audiophile components where possible, and also a different IC and some different transistors. And the question is, will it be better? Will it be worse? Well, I think we can all agree that using so-called better components, it's not going to perform any worse than the original. Or will it sound exactly the same? We're going to have a conclusion at the end with some things that you can change to make this a little bit better. Now, I have to say that the test you've seen on the previous video, which if you haven't seen it, you should see it, because this won't make any sense unless you know what we discovered on the first video. Now, I have to point out right away that my colleague Ron in America has done all the work on this. He's sourced the components and built it and done all the photography. All I've done is basically edited it together. I'm going to show you all the results. First of all, we're using Nichicon audio quality capacitors, and the input capacitors are going to be Weimar. The other changes that we've made to test, again, one or two people have said the BC54656C are cheap junk transistors. I can't really agree with that. To make a comparison, Ron has replaced them with a 2N3904 stroke 3906 for the NPN and PNP version, which are generally regarded as a pretty good transistor. But obviously they do have to have similar characteristics, otherwise it wouldn't be a fair comparison. The original chip as supplied in the kit is the 5532, and I'm very pleased to say that it is a genuine component. It's not a fake like they tend to be in many of these Chinese kits. An IC which we've used as an alternative is the LM4562, which incidentally is also exactly the same as the LME49720, insofar as it uses exactly the same die but has been renumbered. Now, the important thing is, if you use the LM4562, don't buy it from China, because you can guarantee, like the 5532, it's going to be fake, and any advantages that you'll see on this you won't get, and it will probably perform worse. And where these fake chips fall down is usually slew rate, because they are cheaper chip in disguise, basically. So don't do that. Buy a genuine one from the likes of Mauser or Farnell, RS Components, whatever is your proper distributor in your country. Another thing I'm going to show you some differences on the actual gain of the preamp. I did point out in the previous video that as standard it comes with a 100 ohm resistor. The lower the gain, generally the higher the fidelity, because you're basically getting more feedback, and that does widen the bandwidth, lowers distortion, and it shows you the importance of using the minimum gain you actually need. All the things that I've shown you on the previous video are worst case figures, if that makes sense. And it's already superb, and that's what I've been listening for the last 2 to 3 weeks. Don't think if you need the maximum gain, this is going to be rubbish, because it isn't. As I said, all the figures I've shown you and comments I've made have been based on the basic kit using the maximum gain. I can't tell you what gain you need. As I mentioned in the previous video, I would suggest you put on a couple of pins or stick a couple of wires out, and you can tap various resistors across it and select which is best suited for your input circuitry, whether it's a DAC or a CD player. You remember CD players? Got plastic discs. Oh, and a comment to make about this. This preamp is not suitable as a phono preamp. You cannot feed a magnetic cartridge into this preamp. It will not work and it will sound dreadful. You will need a preamp that has RIAA equalization. This is the modified board, or in fact the one that's been populated, and you can clearly see some of the changes. For example, the bridge rectifier right in the center has been replaced by discrete diodes. Now the only reason for this is didn't have a bridge that was different. That won't make any difference whatsoever. That was purely done because that's what we had. Now you'll see also that the transistors are mounted on sockets. Now it may look like some of the transistors could be round the wrong way, and that's because the 2N series are wired completely the other way round. The only other point is right at the bottom of the picture you can see 2 preset potentiometers. This is not normally something that one would do, but this was purely so that the resistance values could be changed and matched up for the feedback and gain test. So again, this is a test board and was the actual board used in the listening tests that follow. The first couple of slides I'm going to show you a very low frequency square wave of 2 Hertz. This shows you the difference when you're using the maximum gain of the preamp, which is with the 100 ohm resistor, and the second slide is showing exactly the same frequency with the 1.1K resistor. In other words, the minimum gain. And you can see quite clearly, if I switch between them, one has clearly got a much lower frequency response. But again, I must emphasize, we're talking about 2 Hertz, and it's there just to show you the effect of a lower gain. Time to let the cat out of the bag and tell you which transistors were which. Well, the BC range was the yellow trace and the blue trace was the 2N series. And the conclusion that I would make on it is the original transistors as supplied with the kit are probably slightly ahead of the 2N range. The next two slides are at the other end of the frequency bandwidth at 20 kilohertz. Both these slides, by the way, are at 1.1K, so at the lowest amount of gain. And this slide shows the 4562. The next slide shows exactly the same thing, but the 5532 chip, clearly showing a little bit of overshoot and just a hint of some ringing. Going up somewhat more in frequency, this is 100 kilohertz. I can hear some people saying, oh, that's why are we even looking at that? And it's basically just to show you the speed of the circuitry in comparison with the two different ICs. Now the one you can see at the moment is the 4562, and when we go to the next slide, that's the 5532, and you can clearly see that the chip is struggling a little bit. There's a little bit of overshoot, and also the sides are sloping somewhat more, which again is an indication of a poorer slew rate. The next couple of slides, pretty well extreme square waves. Now, if you look at most amplifiers or preamps, you would look at that, particularly if you look at some of the, like the quad, that's better than the quad is at 10K, to be honest. That's at 300 kilohertz, 4562. The next slide you can see exactly the same thing, except that's the 5532, quite slower in comparison and is not a terribly good square wave. This one shows you exactly the same as the last two, i.e. the 300 kilohertz. The previous slides showed you with the out of the box gain with 100 ohm resistors. This is using the much lower gain and the higher value resistors. Now, as you can see, it cleans it up quite a bit, and it just basically goes to follow on with what I've said, that don't use more gain than you have to. This is for illustration purposes only. Nobody on this planet is going to be listening to 300 kilohertz. It goes to just show you the difference between the different gains and the different frequencies. So to sum up, the kit of parts that you get for that astonishingly low money are fine. They really are, and all the results given on the first video are based on those components. But as you've seen from this, for tiny bit more money, don't change the transistors. There's absolutely nothing wrong with those. If you think there's a gold-plated wonderful transistor, you try it and report what you've heard. Ron has told me after extensive tests there is no audible difference. The only difference is in using the LM chip, and it's mainly because the slew rate is so much better. Out of the box, it's pretty good. Please change C8, which at the moment I showed you in the previous video was 100 picofarad. Change that to 27 or 30 picofarad. It just cleans things up, particularly depending on the volume control. It suggests you use a 50K. I would suggest, if you can find one, go down to 20 or 25K. They're quite hard to find. Coming up, I've got another two preamps to show you. One of them is very loosely based on a Sugden. I'm not saying it's the best preamp in the world. That's coming up, and there's also a simplified, very simple preamp. This is the simple preamp I'm going to show you. It's for all the people that think the minimum components are the best. We shall see if that's true or not. This is the Sugden. Just thought I'd show you and whet your appetite.